Hey everybody, this is Mr. Ainsworth, and we're going to get into your test corrections for sections 1, 2, 3, and 4 on Chapter 8 here over trig, special right triangles, and also the Pythagorean Theorem. This is version 1. Okay, make sure you understand that. So this is quiz version 1 out of 2 versions. Make sure that you have the following out, okay? You need a calculator. All right, you also need a red pen. You can put down the key points in red. Also, lastly, you're going to do all corrections. Do all corrections on a separate piece of paper. All right, a separate piece of paper. Last thing, what you're going to do is you're going to attach this to the original test and turn it in the next day. Okay, so lastly, when you're done, attach it to the test and turn in tomorrow. Turn in next day, whatever that day is, right? Okay, so pretty self-explanatory, pretty easy to do. So if you haven't got all those things ready, pause the video and get ready here because I will not accept it in any other fashion. Either you do it right this time or you don't do it at all, everybody. So pause the video, get ready, and then press play when you're ready. Okay, so let's get started here. All right, number one, first of all, SOHCAHTOA. Okay, we got to apply our trig. When you're trying to find one side, when you know one side in an angle, it requires trig. Okay. Now, sine is opposite divided by hypotenuse. Cosine is the adjacent side divided by hypotenuse, and tangent is the opposite side divided by the adjacent. All right, that's what SOHCAHTOA stands for. It's an acronym. The very first thing that you have to do is that you have to identify the opposite sides and adjacent sides. So you start at your angle, not the right angle, but the angle of the acute angle. This is the acute angle. So you start here. So your focus point is up here at the angle. And you go to the farthest side away. It's called the opposite side. Okay? The side next to it, well, guess what? Adjacent means next to, so that's the adjacent side. And the side opposite the right angle, well, that's called the hypotenuse, and obviously it's the longest side. Okay? So the very first thing you do is you label the triangle properly, and then you begin. All right? And I know that the opposite divided by hypotenuse ratio, opposite divided by hypotenuse, happens to be the sine function. Sine is opposite divided by hypotenuse, so the sine of the angle, 53 degrees, is equal to x divided by 16. Okay, you're going to be doing three things here. You're going to be setting it up, and this is called a setup. That's step one. Step two, you got to show process. Okay, I want to see how it's done. I want to know that you know how it's done. So let's talk about that right now. When you have a variable and it's been divided by 16, and you got it equal to the sine of 53 degrees, you got to do the inverse. And the inverse of dividing by 16, well, that's multiplying by 16. So notice that I do that on both sides. Here and, whoop, not there, here. Okay, so you multiply both sides by 16. Then you cancel out a little bit. You simplify. 16 divided by 16 is typically 1, especially tonight at 8:54 p.m. All right, and you get the exact answer. 16 times the sine of 53 degrees is equal to x. That's called the exact answer, and that's what you're looking for. And then you go to step 3. You get approximation. How you do that? You use a calculator, right? So let's do that. Let's bring up the calculator here, your TI-84 or your simple TI-30. I don't care what you use, just use a scientific, and you just type it in directly as you see it. All right, 16 times the sine of 53 degrees. All right, the only thing you have to be careful is the mode. Now, let's go to mode. Make sure it's in degree mode. And if it's not, use your arrow keys, go down there and turn it on, all right? You got to be in degree mode. All right, so let's go back, go second mode, which is quitting out. Oh, my calculator's going slow here. Okay, hit the enter button. And you get about 12.77. There you go. I'm going to pause the video for a second. Okay, so what you want to do is you want to round it to the nearest tenth, all right, or nearest hundredth, excuse me. So you look at the third digit, it's an 8, and you round the second digit to an 8 because you got to round up, all right. Nearest hundredth means you take the third digit, Look at it. It's bigger than 5, so you round the 7 up. So it's 12.78. So 12.78 is approximately equal to x. And I'll tell you what, the leg is always smaller than the hypotenuse. And that answer is smaller than 16, so my answer makes sense. Always check your answer and make sure it makes sense. The leg has to be shorter than the hypotenuse. And obviously 12.78 is less than 16. So my answer makes sense. So one thing you got to do is you got to set it up, step 1. Step 2, you got to show process. Tell me how it's done. Step 3, get the exact and get the approximate by using your calculator. Pretty simple. All right, so let's change things up. Let's solve another one. Number 2, adjacent to the angle is x here. Let me put that in red so you can see things just a tad bit better here. Adjacent means next to, so next to the angle is x here, and it's adjacent. The hypotenuse is opposite of the right angle here. It's the longest side, so it's 18. And the function that deals with these two right here has to be the cosine function. Cosine is adjacent divided by hypotenuse. So the cosine of your angle, 66 degrees, is equal to x, the adjacent side, divided by the hypotenuse. And that's called your setup. As I said, every single problem in class. That's step 1, set up the problem. Step 2, show me how it's done. Multiply by 18. Show me the simplifying. So I can see right there that my exact answer is 18 times the cosine at 66 degrees equals x. Okay, that's called your exact answer. Label that. And I want you to pause the video right now, and if you haven't labeled these things, exact and approximate, then do so. I'm going to know if you did things right and you watch my video as if you do the things I asked for. Because once again, you got to do things right. You got to change the way you do things, because if you don't, you're going to get the same results you did before. Okay, so let's get better. All right, do things the right way. Be precise and learn how to do it right. Okay, 18 times the cosine of 66 degrees. Look how, I mean, the TI-84 is so simple to use. You just type it in directly as you see it and write the answer down, 7.32. So 7.32 is approximately equal to x. And guess what? The smallest side is got to be the smallest value, right? And 7.3 is obviously smaller than the 18, excuse me, the hypotenuse. So my answer makes sense. Make sure your answer makes sense. Write that down on your test. Do that so that I know that you actually watched the video and that you actually listened to this. Okay, make sure your answer makes sense. All right, it's pretty obvious that the shortest side has to be the smallest value. So 7.3, much smaller than 18. I know that I'm on the right track. All right, let's continue. Number 3, opposite of the angle. Opposite of the angle. Put your pencil at the angle. Go to the opposite side. That's 18. Adjacent to the angle is right next to it. It's x here. So opposite and adjacent, well, that's the tangent function, right? So, ka, toa, all right? Toa, tangent, opposite divided by adjacent. So tangent of your angle is equal to 18 divided by x. Now, if I'm going too fast, remember, this is a video, right? So learn how to use your technology wisely. Pause and play, rewind if you need to, and go through the lesson. All right, do whatever it takes. Now here the denominator is x, and I don't want the variable in the denominator, so I'm going to clear the fractions by multiplying by the variable. I get x times the tangent of 51 degrees is equal to 18, and I'm still not done yet, because guess what? X is not isolated. So I do the inverse of multiplying. I divide, because in algebra you always do the inverse. So you got to divide by the tangent of 51 degrees. Tangent of 51 divided by itself is 1. Anything divided by itself is 1. And I get my exact answer. 18 divided by the tangent of 51 degrees. What is that approximately equal to? I don't know. I got the exact, but I need to get the approximate. So we use a calculator again. 18 divided by now the tangent of 51 degrees. Get about 14.58. So 14.58. I expect an answer a little bit smaller than 18 because it's shorter than 18. Well, and I got it. Okay. So there you go. That's all there is to it, believe it or not. On number 4, we want to find the indicated angle. All right, I'm going to call that x. Now, opposite of x is 5. The adjacent side is 14. That calls for the tangent function. So the tangent of my angle x is equal to opposite 5 divided by 14. That's called a setup. Now, to solve for the angle, all right, to solve for an angle, you always take the inverse of that function on both sides. All right, so what we're going to do, and let me show you in red, is that you take the inverse tangent of the left side and you take the inverse tangent of the right side. Okay, well, what is the left side? Well, you take the inverse tangent of tangent x. See that? Right there. And then you take the inverse tangent of 5/14. Having computer difficulties running slowly here. All right, so there you go. You take the inverse tangent in red of both sides. Everybody say inverse tangent. In fact, let me write that down. Inverse tangent. And if you put it on your calculator or type it in, well, it's exactly the same as what it looks like. So let me show you. Okay, let's clear out the calculator. Go second tangent and look at the symbol right above it. You'll see it right there. It looks like tangent to the -1 power, but you don't say that, okay? You say inverse tangent of, not times, but of 5/14. 5 divided by 14. You just type it in. It's easy. All right, hit the enter button. Come on, my calculator's running. Actually, my computer's going slow. And so I didn't mean to hit it twice. 19.65. Okay, x is equal to, these cancel each other out. X is equal to 19.65 degrees. All right, it's an angle. So you label it in degrees. Mathematics is a precise science. So remember, when you take the inverse tangent of tangent, you get the angle. All right, the functions cancel out. And you get the angle here. And that's equal to the inverse tangent of 5/14. Remember, if you wrote it like this, 5/14 times tangent inverse, as some people do, all right, that's a no-no, that's bad. Okay, so don't do that. You take the inverse tangent of your ratio, not the other way around. In fact, watch this. If I reverse the order, and I'll show you a mistake. 5 divided by 14, and then I go inverse tangent. Now, a lot of people write it like this because they don't want to write it out in detail. They're lazy, they get slow. All right, watch this. Hit the enter button or the equal button. Error, syntax order. The order, syntax means the order is in the wrong way, okay? All right, it's in the wrong order. You got to take the inverse tangent of what? Well, 5/14 should be inside those parentheses, just like I wrote it right here. So make sure you write it correctly. Okay, let's move on here. And let's go down to problems 5 and 6. Now, problems 5 and 6. Now, you got to find the missing side lengths. All right, leave your answers in simplest radical form. On the special right triangles, the 30, 60, 90. This is the 30, 60, 90, and the 45, 45, 90. All right, these do not require calc, so write down no calc. All right, no calculator, and also no trig, okay? No trig required. So remember that. You just have to remember your basic facts. Okay, you got the hypotenuse here, the longest side. You got the shortest side. And some of you guys might be thinking, okay, why is it the shortest side? Well, it's opposite of the smallest angle. That's why. And then you got the medium length side right here. To get from hypotenuse to short, you divide by 2. To get back, you multiply by 2. To go from short to medium, you multiply by rad 3. To get back, you divide by rad 3. That's what you should have learned in your lesson. So n here is 7 divided by rad 3. That's all it is. But you got to rationalize it. Everybody say rationalize. Okay, I talked about that in class. I asked you guys write that down and let's practice that. Now, in red, watch this. I'm going to rationalize it. I multiply it by a form of 1. 7 times rad 3 is 7 rad 3. Root 3 times root 3 is root 9. But 7 root 3 divided by root 9, which is just 3, can be simplified. So n, okay, is 7 root 3 divided by 3. And don't think you can cancel these right here. They do not, or you're not allowed to divide a root by non-root. Not allowed, okay? So you cannot divide a root by non-root. So you're done here. Okay, so this is 7 root 3 divided by 3. Then you got to double that to get to the hypotenuse because the hypotenuse is equal to 2 times the short side. So here we go. M is equal to 2 times 7 rad 3 over 3. Well, that's simple. That's 14, right? So 14 rad 3 over 3. 14 root 3 divided by 3. 2 times 7 is usually 14, right? And there you go. You're done. That's called simplest radical form. Now this one here on the 45, 45, 90, when you go from hypotenuse to leg, all you do is divide by rad 2. And you got to remember this is isosceles. So once you whoops, isos, so these, there we go. Once you find one, you got the other one, right? Okay, so A equals B first of all, and that's equal to 10 divided by root 2. You got to divide by rad 2. Rationalize, as we always do, and you get, well, 10 rad 2 divided by root 4, but that's 10 rad 2 divided by, well, root 4 is 2, all right? Now you're allowed to divide here because they're not roots, right? So 10 divided by 2 is 5, and you get rad 2. So A equals B, which is equal to 5 rad 2. They're both 5 rad 2 here and here. Okay, they're both 5 rad 2. Why? Because it's isosceles, my friends. They're congruent. Okay, that's a very simple concept which we've been studying for a long time. Okay, remember this is a video, so you can always rewind if I go too fast, which for some of you guys I know I am. So go ahead and rewind it and listen to it again. Listen to it 2, 3, 4 times. Practice it 2, 3, 4 times and you'll start to get it. Okay, on this one here, you want to leave your answers in simplest radical form. No calculator, no trig. Write that down, okay? This is called the Pythagorean Theorem. Write that down too. Pythagorean Theorem. Now, Pythagoras, back 600 years before Christ, about 2,600 years ago, stated that if you take the legs, okay, and you square them, so leg squared plus leg squared, that's equal to the hypotenuse squared. All right, so what you do is this: you take x squared, add it to 4 squared, and set that equal to the hypotenuse squared. And I know you guys thought of it back in the day as a squared plus b squared equals c squared, but so many people forget what c stands for, so I hate stating it like that. It's leg squared plus leg squared equals hypotenuse squared. So many people messed up the formula on the test because they didn't know which was which. What's A, what's B, what's C? Well, let's not remember it like that. It's leg squared plus leg squared equals hypotenuse squared. So make sure that you write this down right here. That's very important for the Pythagorean theorem. Okay, now we got x squared plus 16 is equal to 64. Subtract 16, you get x squared is equal to 48. Now here comes the fun part. You got a square root, and you get x is equal to this. Now 48, you got a factor. Divide by 2. Now you can also do this in your calculator. 48 divided by 2 equals 24. So you put 24 down, right? But anytime you have an even number, you divide it by 2. So divided by 2, that's 12. Divided by 2, that's 6. Divided by 2, well, that's 3, right? Divided by 3, and so on. So 12 divided by 2 is 6. Divided by 2, 3 divided by 3 is 1. You're looking for squares, so let's find them. There's 4. There's 4. I just found it. 16 is my biggest squared. So these are the factors right here. 3 times 16 is 48. So you split the root. Root 16 times root 3, well, that's just 4 root 3 and you're done. That's called simplest radical form, my friends, and that's what we've been practicing for months. Get good at it, okay? Now, on the next one here, you got your legs, you got your hypotenuse. That's the hypotenuse. Opposite of the right angle is the hypotenuse. So this is 4 squared plus 6 squared is equal to x squared. Leg squared plus leg squared equals hypotenuse squared. Or you can say 6 squared plus 4 squared, but it's the same thing, right? That's 16 plus 36 equals x squared. That's 52 equals x squared. And now again you root, just like you did on the first one, right? Now you split the root. Write that down too. You got to split the root and go for it. So 52 divided by 2 is 26. Divided by 2 is 13. That's prime. The only square is 4. 4 times 13 is 52. So root 4 times root 13, that's 2 rad 13, and you are done. Okay? That's called simplest radical form. And that's all there is to it. You guys have really got to go down to basics. What I want you to do now, after you do this, I want you to print another copy. Print another copy of this, of the quiz and practice. I'll put up a student copy version, and I want you to do that right here. Now check this out. Make sure you do that. And then after you do that, again, look up here, go back up to the very top. I asked you to attach a copy, right? Attach your corrections. Attach the corrections I'm talking about. Corrections and practice copy, okay, to the original test or to the original quiz. And then turn it in. Okay, so you're going to be turning in your original quiz, your corrections on another piece of paper, and your practice. So 3 things. And again, I think that's pretty darn clear. If not, rewind the video and listen to me again. Turn in the quiz, your corrections, and the practice, which is obviously printed off by you. Do that, turn it in the next day, and get prepared. Because let me just put it this way. If you do the same thing, you'll never get any better. You got to try something different. You got to be better than you were the previous day, and you got to fix your mistakes. Otherwise, you're not going to get any better. All right. The definition of insanity is this: if you do the same thing but expecting different results, you got to be insane. All right. Do something different. Do it right and do it well. Perfect practice makes perfect, not just any practice. The quality of your work matters. So do it the right way and do a lot of it, and you'll become better. And I'll see you in my next lesson. This is Mr. Ames. We're signing off. I'll see you then.